Let's take a quick look at a sample calculation involving an acid-base titration. So in this titration, I have sodium hydroxide being added to an unknown strong acid. I'm using the general formula of HA just for a generic acid, forming sodium A. So this is a salt and water. So remember, a neutralization reaction forms salt and water, and the acid-base titrations are all, that's the products that we're working with. To be able to perform this calculation, I'm going to need the concentration of my sodium hydroxide. So I have 0.100 molar NaOH. You may have a different value, so you do need to make sure that you are reading that off appropriately or calculating it depending on how you're performing that calculation. And this is just a sample of what my data might look like after I perform my titration. So let's say I performed my titration using 10 milliliters of my acid from a pipette. It's a volumetric pipette. So I record my volume, 10.00 milliliters. I've got my final burette reading, I've got my initial burette reading. So now I need to find my volume of NaOH and everything else here. So my volume of NaOH, it's going to be my final burette reading minus my initial burette reading. Do make sure that you are subtracting the smaller number from the bigger number. And I get that I have 47.80 milliliters. Do make sure that if you have the same digit here and here that you do retain that 0 because it is a significant figure. So this is going to be part of what I'm going to use to find my moles of NaOH, and then I'm going to use that to find my moles of an acid and then my molarity. Okay? So first we're going to find my moles of NaOH. A key to this is our molarity here. So remember, if we have a molarity, we can convert molarity into our moles per liter because the molarity of a solution is equal to the moles of solute for every liter of solution. So I'm going to convert my concentration of NaOH here into 0.100 moles of NaOH. NaOH is our solute, that's what's dissolved in our water, for every 1 liter of solution. Now, I want my moles of NaOH, so I need to get rid of that liters. Liters is a volume, and we have the volume of NaOH that I've used. I've used 47.80 milliliters. Oh, but that's not going to combine because I have milliliters here and I have liters here. Different units. You can only, you have to have the same units throughout. So I'm going to convert my milliliters into liters. So times 10 to the third liters for every 1 milliliter. So this is a good review of your so 0.04780 liters. So this is going to be a good review of your conversions. So do make sure that you are reviewing this as we go along. So I have 0.04780 liters. I can use my molarity here as a conversion factor. Times 0.100 moles NaOH for every 1 liter. So remember, this is our liters of solution. Liters of solution. And calculate that out. So now I have 0.00478 moles of NaOH. I've rounded it to 3 significant figures because I have only 3 significant figures in this molarity. If you have more units in your molarity, you can have more units in your answer here. So this is our moles of NaOH. We have the balance. it, but we want to find our moles of unknown acid. So moles of NaOH here, we've got 0.0078 moles. You can also write that in scientific notation. Now I want to find my moles of unknown acid. So I'll show you how to do that in just a minute. So let's find our moles of acid. So we know our moles of sodium hydroxide, and we have our balanced equation. So remember, our balanced equation gives us the mole ratio. And the mole ratio is based on the coefficients. If there's no coefficient in the balanced equation, remember the coefficients are equal to 1. So we have a coefficient of 1, 1, 1, 1 throughout there. So that means that for every 1 mole of sodium hydroxide, I'm going to have 1 mole of acid. That's my acid is my HA. Okay. So if I have 0.00478 moles of NaOH, I can convert it. So I have 1 mole HA for every 1 mole NaOH. So I have 0.00478 moles of HA. 0.0478 moles. And I've changed colors just so that we can keep track, because we do want to make sure that we're careful about whether we're working with our acid or working with our base. Now, the last step here is I want to find my molarity of my unknown acid. So remember, our molarity is our moles solute divided by the liters of solution. So we know our moles of solute. In this case, our solute is HA, so we have 0.00478 moles of HA. What's the liters of solution? So this is the volume of our solution. Specifically, we're looking at the volume of acid. Volume of acid here is 10.00 milliliters. So once again, we're going to have to convert that into liters. 10.00 milliliters. Liters per 1 milliliter. So that gives me 0.1000 liters. 0.000 liters of solution. So I can divide through. Eight divided by 0.01, and I get my molarity for my HA is equal to 0.478 molar HA. 0.478 molar. So keep in mind that for finding your average molarity, you would need to know what the molarity is for each of your individual trials. There is an alternate way that we can calculate this, and it's based off of that mole ratio from the beginning. That we have 1 mole of sodium hydroxide is going to be equal to 1 mole of HA. We know this because we're doing our titration to equivalence. We want the moles of base and the moles of acid to be equal. To find our moles of sodium hydroxide before, we multiplied the molarity of our sodium hydroxide times the volume of our sodium hydroxide. To find the molarity, the moles of our HA, if we knew the molarity of HA, then we could do that as well. Volume HA. So essentially, I've derived a new equation that I could use to convert between if I know the molarity and volume of our sodium hydroxide and a molarity and volume of our acid. So let's see whether this works. So the molarity of my sodium hydroxide was 0.100 molar. My volume of my sodium hydroxide was 47.80 milliliters. I'm not even going to convert it. Let's see whether it works this way. I want to look for my molarity of my HA. That's what I'm solving for. And my volume of HA was my 10.00 milliliters. So if I plug all of this into my calculator, so I divide both sides by my 10.00 milliliters to get rid of it. By 10.00 milliliters. Plug all of this in my calculator, so 0.100 times 47.80 divided by 10.00. I get that my molarity of HA is equal to 0.478 molar. Now you do want to make sure that you can do it both ways. This way is a whole lot faster, but you do have to be very sure that you have something where you have the moles equal in this balanced equation before you use it.